So today I'm gonna go ahead and do a quick physics review. I'm just gonna go through some of the basic things that I've noted from like my notes and some of the worksheets that we've gotten. And I've just compiled like small list of vocabulary and some questions. So I'm just gonna go ahead and read the questions and write the answers for each one of these. So first we have weight. I'm gonna go in random order, not in the order that we went in class. So just note that. Know this formula, as we may have a few examples since we discussed it later in the year. The grams on Earth is 9.8 meters per second squared. So just know that number because it may come up in some formulas and it's not given to you. Force equals mass times acceleration. Just remember you know that formula as well. Next we have, so what are field forces? So field forces, it's one of those words that we didn't really review except in the section review. So these are when a body, when a body exerts, can't type at all, can I? An influence into the space around itself. Oh my god, I really can't type. Such as gravity, and that'll fix by itself, and electric forces, perhaps. There we go. Great. So then we have, what are some contact forces? So contact forces, this is any force that requires contact to occur, such as normal force, since you have a base or a surface. Next we have, what is the SI unit of force? It's kilograms times meters per second square. Next we have, what is force a vector quantity? So it's force, it's a vector quantity, because the effect of force depends on magnitude and direction. And we know that vectors have magnitude and direction. So there you go. So what if we brought diagrams versus force diagrams? So maybe you shouldn't know too much about this. Maybe you should just look at the picture and know how to identify it, but they're very similar in definition. Free body diagram shows the forces acting on an object, whereas force diagram only shows the forces, but in a different way. Like I said, they're very similar in definition. So I would recommend you go look up a picture of this so you can sort of identify them. But we'll mostly be doing free body diagram for the midterm, I believe, though. You never know. What is weight? So weight is the pull of gravity. And it's, you know that it's always facing downward. What is tension? So tension is a pulling force. So when you're pulling from something, and this is toward the direction of the puller, whatever is being pulled. Then we have, what is normal force? So here we're talking about forces, okay? So just remember, normal force is sort of like the force it's provided by the surface. So if you have a surface, you have normal force. And it is perpendicular to the direction of the surface of whatever, if you're drawing this out. Next we have, what is friction? Friction is the force that exists between materials in contact. It faces against the direction of whatever is in motion. Next we have, what is a simplified equation of acceleration? And this would simply be A equals change in v over change in time, velocity time. Note that change is the same as delta. I simply cannot do it right now. Acceleration is defined as, acceleration is the rate of change in velocity. If you know a car's acceleration, then you must have the information to determine, then you must have what to determine the car's velocity is increasing. If the car's velocity, you have to have the direction of the car's initial velocity. If you know the acceleration of a car and its initial velocity, you can predict which of the following. You can predict the direction of the car's final velocity. You can predict the magnitude of the car's final velocity and the displacement of the car. And these are all based on the formulas. So if you know the formula that we're using, you would know what's left, and that would be final velocity. Okay, so next we go into what a hypothesis is. I believe that's what it is. So a hypothesis is a prediction of the outcome of the experiment. Know that you should know it has to be logical, it has to have a testable explanation of an observation, and it must follow something from what you already know. So these are considered the basic things you should have in a hypothesis. Not entirely needed, but it doesn't hurt knowing them. Next, we have what's an example of a good hypothesis. So, for example, a good example would be if I clean the window with water, then the window will be clean. Next, we have what is scientific inquiry. So, scientific inquiry is simply the way scientists investigate a problem. And within scientific inquiry, you have 4 steps, which are where step 1 is where the scientist proposes a question to be studied. Then you have he or she creates a hypothesis based on observations and previous knowledge. Then you have the next step, which would entail of them. He or she conducts an experiment and records data. Then you have he or she, after analyzing it, of course, will draw a conclusion that either supports the hypothesis or shows how it's connected. So you may not know to know the steps, but it wouldn't hurt to know them. So why not? Why not? Okay. How long does a hypothesis need to be in order to carry a valid experiment? As long as necessary. Next up, we have, let's see what else. So what are some examples of scientific inquiry? So we could say probably testing the effect of a new drug on a disease, or measuring how tall plants grow when given different fertilizers. These are some good examples of what scientific inquiry is. Okay, next we have what are mechanics? So mechanics, these are the types of physics that sort of subsets that we knew at the beginning, but we didn't really go through them. Mechanics entails motion and its causes, interactions between objects. Next we have what are thermodynamics? Oh, look, I'm writing the question. Okay, question. Thermodynamics are those that involve heat and temperature. Just remember the word thermo as temperature, and that should do the trick. Okay, after 20, there was something else. So the question read sort of, in order for a hypothesis to be valid, the statement needs to be testable and falsifiable. Just know that. And know that in order for a scientific inquiry to be considered valid, the data doesn't always have to support the hypothesis. Just know that. Anyway, next up is what are vibrations and wave phenomena? So vibrations, wave phenomena are those specific types of repetitive motion. So anything that includes some sort of repetition in its motion will be considered this. So then optics. Optics involve light. Then you have electromagnetism. Electromagnetism is those that involve electricity, magnetism, and light. Next we have, what is relativity? So relativity includes particles moving at any speed, including high speeds. Next we have, what are quantum mechanics? Quantum mechanics are the behavior of what submicroscopic particles, or more or less is. Okay, then we go into models. So models are known as patterns, plans, representations, or descriptions designed to show the structure or workings of an object. Next we talk about what is a model. Well, no, what is a system? Systems are a set of particles or interacting components considered to be a different, or not different, well, I guess, physical entity for the purpose of study. Just notice where there's a chance there needs to be a multiple choice or something, so, yep. What are the first steps in scientific method? So in the scientific method, we have first make observations and collect data to lead to a question. Next step is formulate and objectively test the hypothesis. After this, we have interpret results, which is key. And then we have state conclusions in a form that can be evaluated by others. What is controlled experiment? So controlled experiment is an experiment that tests only one factor at a time by using comparison of a control group, experimental group. There you go. Next we have what is accuracy. So accuracy is the description of how close a measurement is to the to the correct value or accepted value. Then we go into the other one, which is precision. So precision is the degree of exactness of a measurement. So what are significant figures? Significant figures are digits in a measurement that are known with certainty, plus the first digit that is uncertain. There we go. Next we talk about what is frame of reference? Frame of reference. So frame of reference is the system for specifying the precise location of objects in space and time. No, not 8. That's wrong. So what is displacement? So displacement is the change in position of an object. What is average velocity? So average velocity is the total displacement divided by the time interval during which the displacement occurred. Next we'll talk about what is instantaneous velocity. So instantaneous, coming from instant, is pretty much the velocity of an object at some instance or at a specific, oh my god, okay, point. What is acceleration? So acceleration is the rate of which velocity changes over time. Next we have what is a decrease in speed called. So a decrease in speed is called deceleration. What is free fall? So free fall, it refers to the motion of a body when only the force due to gravity is acting on the body. Next we have what is scalar. So scalar, I said that wrong, is a physical quantity that has magnitude but no direction. What is vector? So vector is a physical quantity, cannot spell quantity, that has magnitude and direction. What is a resultant? So resultant is a vector that represents the sum of two or more vectors. Then we talk about what is magnitude. Magnitude is the size or quantity. I really cannot spell quantity, can I? Next we have what are the components of a vector? So this is kind of a vocabulary word. So the components of a vector are projections of a vector along the axes of a coordinate system. Just know the definition, even if it doesn't make sense to you. Maybe if you read it a couple times, it'll make sense. What is force? So force is an action exerted on an object which may change the object. Whoa, I went really deep there. Okay. Object's state of rest or motion. Okay. Then we have, in describing the motion of an object, it is often helpful to identify what? Which allows you to describe the motion relative to that of another object. So it's important to identify the frame of reference. Average acceleration can be found by determining what of the straight line connecting the initial and final points on a graph of an object's velocity versus time. So the average acceleration can be found by determining the slope. Of course, the slope of the straight line connecting the initial and final points. Okay. Next we have the constant acceleration directed toward the center of Earth exerted on all objects on Earth's surface is called acceleration due to gravity. Next we have the constant that's just it right now, never mind. An object in free fall experiences a constant what? So an object of free fall experiences a constant acceleration. Remember that. If it's free falling, it has constant acceleration. In the Pythagorean Theorem states that for any right triangle, the squares of the equals the sum of the squares of the other two sides of the triangle. So the square of the hypotenuse would be. Next you have velocity measurements depend on what from the observer? On the observer. Depend on the frame of reference. So make sure you know what frame of reference is because it's appearing quite a lot in this exam, but aside from that, that would be it for this video. Thank you guys.